And I'm here with Erdem Öztürk of Productive Machines and Pascal Weber of Manukai, two pretty
Hi.
awesome startups, as you're going to learn about in a minute. We're very happy to join you today. I'm a little stressed because I just got off a train that was late, and Pascal has a video problem, so we're going to take a nice breath and we'll get started. So let's start with Erdem because he was the one on time. He gets to do his introduction first. So tell us about you and tell us about Productive Machines.
Yeah, of course. I'm Erdem Öztürk. I'm the founder and CEO of Productive Machines. Productive Machines is going to be a 5 years old business in March. It's a spin-out from the Advanced Manufacturing Research Center at the University of Sheffield. I worked there for a long time, more than 10 years. We developed a lot of technologies that helps main aerospace companies. But there was one particular technology, which was a digital twin for machining processes. And we took that technology out to the wild world of commercial world. And since then, we have been growing the business. Yeah, that's a short intro from me.
Yeah, we'll hear more about what you're doing as the podcast goes on. I just left your country, Pascal. I just came out of Geneva. I just arriving in Paris.
Yeah, I thought you could have came by here. That would be been
Zurich's not
easier
right next
because
door.
well, but trains are on time here in Switzerland at least.
Well, for those that don't live in Europe and maybe don't know that, it actually turns out that ETH Zurich, well, I think there's two technical universities there that are turning out these amazing startups. So I've already had two or three on the podcast. Manukai is yet another one. So I just wanted to point that out, that if you guys didn't know that, I mean, there's like in Germany, there's a group in like Western Germany around Karlsruhe. And then in England, you have Imperial College, Royal College, Sheffield, and Warwick. In France, well, you've got France, and then in Zurich is a hotbed, and then in Germany, it's more or less Munich and Berlin, where all the startups are, right? So, pretty interesting. I think you're in Germany, right, Erdem?
No, we are in Sheffield. We are in the United Kingdom, England.
The UK in England. Okay, yeah. Okay. Well, so Pascal, tell us about Manukai.
Sure, yeah. So, hi everyone. I'm Pascal Weber, co-founder and CEO of Manukai. Our story is a bit different. So we studied like fundamental research in applied AI. So how we can really use AI models that come fresh out of the frontier labs and then basically kind of misuse them for engineering and science applications. And yeah, so after doing all this studying and researching during the PhD, my co-founder decided that we want to do something in the real world. Turned out manufacturing builds the real world, so that's a good start. And then found our way to CNC machining, where we believe we have the greatest potential to actually change how we produce things today.
Yeah, I bet there's a lot of startups digging in that very rich mine of CNC. That's great. So we always started the podcast looking back a couple of years, and when you think about 2022, 2023, OpenAI announces this ChatGPT thing, and obviously the people in the know knew there was a 1 and 2, but all of us learned about 3, and the world seemed to change. It seemed to be a bit of a pivot point. Were you guys skeptical or really bullish about the possibilities of how it would change engineering and change manufacturing at the beginning?
Who is first?
Go ahead, Pascal. Pascal, you want to do that one?
Sure. So I mean, being kind of an AI researcher, right? I was initially very skeptical.
Of course, you knew about it.
I still am, because I think in manufacturing, right, the language and imagery is not really the kind of modality. Of course, for quality inspection, you can use the image recognition capabilities, but language, I think, is still a bit of a scratch for being used in manufacturing. So I think still today, right, there is still, I think, big steps needed to actually adopt and create AI models that can deal with the type of data that we deal with in manufacturing and CNC machining.
And what about you, Erdem?
Yeah, large language models were very useful, like in daily lives. Like I started using it in my personal life, like get some advice, like review this, review that. Like it can consume documents very quickly and then give summaries. But yeah, initially Productive Machines technology was not going to be influenced by AI with a large language model. What we have is we have a physics engine. So we basically simulate the mechanics and dynamics of the process, like cutting forces, tool stresses on the tool, torque, power, vibrations, and we work on a very specific vibration type called chatter vibrations. That's the bad vibrations for the sector. I don't see that AI would have any influence on those things. For that reason, yeah, we didn't use it. But yeah, as it gets better and better, of course, we are using it in the company, especially in the product development, to accelerate the development times. But yeah, we have our own solution. I don't know how to call it, but it's basically like physics engine. I think it can be called agentic AI, although it may not be really correct. We have a simulation engine, and then there is a algorithm running that engine. So it's like an agentic AI we had in the past, but it's not like the agentic AI that is now promoted by the companies like OpenAI and Claude.
And N8N. So you both were sort of skeptical and kind of a wait and see mode.
Yes.
However, I imagine that you guys are both using AI in terms of a development tool, right? For maybe automatically writing PRDs, probably a lot of code also. So the first part of that question is, so how are you using, or how are the developers at Manukai and Productive Machines using AI on a daily basis?
Yeah, all developers have access to it, so that we have the enterprise version of the solution. So
which one, Cloud Code or
we use
Cursor, ChatGPT?
ChatGPT, and the guys are using
Vertex, right?
to accelerate the development time. I can give a very specific example. We started with cloud, so we were cloud native. We thought the future was cloud when we started, and then we developed autonomous optimization software, which is kind of basically enabling any CAM programmer to optimize the processes by pressing a few buttons. But then we faced the reality of the market. Market didn't like cloud solutions, so we had to shift everything from cloud-based deployment to on-premise. So in that transformation, I know that our guys used AI tools a lot because it was like standard processes that the guys followed, and without AI tools, probably we would have the on-premise installation in a longer time frame rather than like 3 months.
So it's useful to reduce the time it took to get the application out. Pascal, what about at Manukai?
I mean, we also use it for the development, especially when it comes to like documentation or pull request reviews, like all these kind of, I think, cumbersome processes that you somehow don't want to do as an engineer. And I think that's I think generally how I think about AI. I think it shouldn't be used to replace, let's say, the core and established work that we know it works, and we have been developing and improving it for a long time, but it can be used as an enhancement to kind of maybe, do replace some of the bottlenecks or do replace some of the repetitive and boring things that no one wants to do.
But are you guys doing some form of vibe coding where you're really just talking to a chatbot and it's generating the code, or are you guys holding off on that? Because okay.
I mean, my opinion is right, and it's the same applies, I think, for applications in manufacturing and CNC machining in more detail, right? I think if you want to produce something production ready, there needs to be a senior engineer there to think about the architecture, to fix and create something that really scales. Because I think vibe coding for us is something that we use for prototyping, for user testing, right? You can basically throw at it like Figma design and some description of a use case, and the thing is going to generate a nice, let's say, website that we can then give to the user to actually test and give us feedback on the ideas we had. But I think after that, if you really want to make it into production-ready code, it's not yet at the stage where AI can be taking all of it. At least not in these very specialized regimes we are working, because I mean, most of the code, most of the data is all proprietary. It's not like standard websites that we are building. I see.
How about you, Erdem?
Yeah, I think it's similar. We don't have like AI generated code in the product. It's more about guidance. So the guys in the development team are using it as a like assistant when they are wondering how to do this, how to do that. So that kind of questions they get. But yeah, we are quite strict about not having the AI generated code in the actual production code.
Oh,
Maybe
so in this case, it's
change
sort
in
of
the
a,
future, but
it's
at
a
the moment, no, it's not in the production code.
so it's more of a sidecar and then copy paste kind of thing. Okay, rather than a full blown environment. That's because it's some of the other founders I talked to. It was almost like having another couple developers on the team, and I had made the joke that maybe the Scrum will be between a couple of agents instead. And I'm wondering too, like in the fact that, well, it looks like it's not the case for you two, but I'm wondering over time if waterfall and agile, these processes are not going to morph into something else because we have AI doing a lot of the heavy lifting that you would use a Scrum to get the crap out of the way, right? To fill out the backlog. I mean, maybe that's where AI agents will be useful to just kind of work the backlog while you're working the new stuff. I don't know, just a thought. What do you guys think?
I have a specific example on that. So there is in the UK, there's a competition called AI Pioneers Award. We passed the first stage, expression of interest stage. Now we are in the second stage. It's a competition available to all the UK-based companies. And basically, one developer is working on it now, and he's using AI tools, agentic AI tools, but it's mainly to demonstrate what is possible. It's not going to be a product. Basically, we'll send a demo, and there will be an interview in March. We'll present the solution, how it works, to the jury, and then if we are successful, we will get 250K prize money, which is quite interesting. But for that kind of demonstration and prototyping, I think it's great. But it will take like a few months to convert that, maybe more even, to a product. Then our guys will be coding, because the code we want to have traceability, explainability. Basically, those are the things that we are seeing missing at the moment with the AI tools.
Do you have any comment on that, Pascal?
Yeah, I mean, to me too, right? I think in the end, it's garbage in, garbage out. That also holds true for these AI models, right? I mean, the degree of specification that you would have to do in order to actually maybe get a meaningful output is more or less the same if you than just writing the code. So I think yes, it can be useful for summarizing things, so for really doing repetitive things, like things where you have all the information there, but you kind of want to restructure it or present it in a different way. But I think it's not yet there, and I think also even the big labs agree on that when it comes to creativity, when it comes to actually creating something really novel and out of the box, it's simply it's simply not in the nature of the training algorithm that it can capture these kind of tasks.
In the chat, Naga Reddy had a question. He asked, is anything you're using AI for in terms of validating on if the tolerance is applicable to the parts is correct?
Sorry, can you say it again? I was distracted.
He said, anything you're using AI for validating if the tolerance applicable in parts are correct. So I think he means like, are you using AI to validate tolerances in the machining process, like using ML or kind of a regression algorithms to determine whether the tolerances are correct.
Okay, maybe I can start the answer. So we have a solution that runs in the process planning stage. We of course get some data from the machine. So we call this we have a method called tap testing. We tap the tool. It's basically simple tapping on the tool, and then we identify the nature frequency systems and damping properties of the machine. And then we run our software called SenseNC, which gives it basically sense to the NC code. And then we do an optimization, and then we create new operations in the CAM environment like NX MasterCam. And then we send the code to the machine, and the machine does the manufacturing. Current product scope is there, but in the future, of course, we will have a solution that gets the real-time data from the machine. At the moment, we rely on the customer telling us, okay, you achieved X% improvement in productivity, Y% service quality improvement. But at the moment, we are not getting real-time data from the machine. We only get basic data from our customers, verbally or by email.
Yes, so maybe since we are a bit earlier in the process, I can elaborate directly on that. So for us it's a bit different, yes, because we get basically the technical drawing, so the PDF with the tolerances well, in the end the step file, right, of the part, and that goes into our engine. And of course, in order to then choose or suggest appropriate production strategies, we need to understand what tolerance requirements are given, what material requirements are given, etc. And this goes in, and yes, there is AI being used, but also here, right? I think tools today are really optimized for more, let's say, mainstream tasks, as I said initially, right? Maybe understanding documents with written text, and we see challenges of using out of the box tools to actually understand more complex technical drawings. And also, I mean, the technical drawing is something that is not very forgiving. So if you misinterpret the tolerance, well, good luck, because you might generate scrap. In the worst case, you might even demolish the machine. So, no.
Interesting. Thank you for that, and thank you, Naga, for the question. I'm wanting to, like, another thing I've been thinking about, and sorry, it's not one of the scripted questions, but I think it's still an interesting one, is that it's kind of, I'm thinking like the next generation of PDM, like, design engineers, CAD guys, they use PDM and they have all these CAD models that eventually you guys have to have in order to do stuff. And yet the PDM doesn't understand anything about machining, doesn't understand G code, doesn't understand tool paths. All it understands is CAD. So how can we get it so that the PDM actually understands, the what you guys are doing? I mean, it seems to me it's a little silly that they're two different systems. It just should be the one. There should be an intelligence system that comes in, like Manukai or Productive Machines, to work on the CAD data and give an output. But then whatever the output is, it should be in the PDM system so I can get to it really easy, right? I mean, it's not rocket science. I don't understand why we're not there yet.
Yeah, exactly. I think whoever closes the feedback loop will be really successful, because I think manufacturing is well known. It's like very segregated industry. Like CAD is different, CAM is different. You have post-processing, you have machines, and then machine controllers. You weren't very open maybe until last few years, until like 5 years ago or so. They were really conservative, sharing data with the outside world. And then there's quality assurance, like CMM machines, like measuring the dimension quality. Like, yeah, so at the moment they are all siloed data. Like, I think it needs to be all. Another problem is the standards. There is no standard of communication. There are some standards coming, but again, there is not. It's not at a state that.
Well, that's what agents are for, right? They're the ones who figure it out. Just give it Moltbook. We create a Moltbook page and let the agents battle it out, right?
Yeah.
Pascal, you seem to have something to say.
Yeah. I mean, in the end, right? I think it's a common problem. It's not just in manufacturing, right? You have the designer, and then you have the engineer building the thing, or the production realizing the thing, right? You have it in architecture. The architect draws the house, and then someone has to build it, right? It's the same in manufacturing. You have basically the designer, and then you have the machine programmer setting up the thing for running. And I think it's just in the nature of the thing. It's kind of two different tasks somehow, to think about how something should look in order to be functional for the design task. But it's a kind of detached from whether you can or how you can actually create the thing in reality. And so maybe AI can help that. A single human can be capable and perfect in both worlds. So being a perfect designer and at the same time being the perfect engineer. But yeah, I believe there is still a long ways to go until we are there, because
and I didn't even throw in the other piece. I didn't even throw the other piece. I think is required is simulation. I mean, when you're doing FE and CFD, why are they different systems? In terms of the file management, why are they different? There's another question from Deniz Bilgili. I hope I spelled that correctly. He says to you guys, which is a nice compliment, he says, so fresh and see, you're both very intentional with your approach and language models for using for the sake, and not just using it for the sake of using it, right? Just not just using AI because it's fun. So his question is, if there are currently 4 to 5 CAM automation optimization, one-click done types of solutions emerging, what do you think will be among the crucial differentiators? I think he's talking about Cloud NC, Limitless, Digital CNC. What do you see as the crucial differentiators in a market getting rather crowded? In your experience, is the direction of product offerings aligned with what the customers need, or is it just again AI for AI's sake?
Yeah, I can give a very specific example on that because it's part of our story. So we had a product that was developed in the university environment in my team, and that product was implemented in big companies like Renault, like in France, and then Mazda Aerospace in Spain, and then we continued to develop it further, and then we implemented this technology in the partners of AMRC in many aerospace companies. And then we thought, okay, now we have the product, let's go out. So we got investment from Boeing, and Boeing said, okay, go and sell this solution to my suppliers, and then my suppliers will be more cost competitive, and then I will gain, my supplier will gain because they will be competitive, and then you will gain because you'll have a customer. And then when we talk to the suppliers, the recurring message that we were hearing was we talked to many suppliers of Boeing. They said, this is great technology, but we don't have the engineers that can run this. I said, what do you mean? Like, we don't want to train engineers on it, and then we don't want those engineers to disappear to another company. And then if they don't go to another company, they get promoted and they become a manager, and then they need to train another person. And basically they said, give us something like that any CAM programmer can use. Like ease of use was the main thing, because there is also a skills gap problem in the UK. I think it's general for the all modern nations or manufacturing nations. And basic ease of use is, I think, a critical factor in terms of differentiation. And of course, trust. Like we learned that trust is very important. So whoever has the the most trust of the manufacturers, then I think they will be more likely to win.
Very cool. I like that answer. Pascal, do you want to field that one?
Yeah. I mean, in the end, I agree with a lot of it. I think interpretability, safety is super important. Is going to be. I mean, it's a must-have. And then I think privacy is another thing, right? I think steel manufacturing is an industry, and it also makes sense, right? Because I mean, everyone can steal a design, but if you don't know how to produce the parts at scale, then it's useless. So what you really want to protect is maybe your really production processes. So I think having a solution that doesn't strictly preserve privacy will be a no-go for large scale adoption. And I think the third one, it also goes into the direction of ease of use. I think it needs to be very tightly integrated into the existing system. So I think engineers don't want to shift their workflow they have been using for 20 plus years. And I think also it needs to be kind of addressing all the intricacies of the different industries, right? So manufacturing has very many of these very specialized niches, and the solution needs to work for basically all these niches, because otherwise you're still just going to be kind of ending up as a solution for like the broad masses, which is probably not never going to allow you to climb the Olymp to the top, right, where the kind of really large OEMs and leaders in the market live.
That's a great response too. It just makes me think that maybe. Well, I know there's a guy named Andy Fine. He has a thing called the Fine Physics Consortium, where he's helping simulation companies that he chooses very carefully as becoming sort of a block. So you've got a group of partners you can work with. Maybe we need that in the manufacturing space too, so that you guys can go and have a sort of complete solution, so that everything just doesn't go to NXCAM and to Delmia, right? Because that's sort of that's more the competition, I think, than anything else. It's going to be Sandvik, and now Cadence, because they bought MSC. Anyway, it's going to be an interesting couple of years, I think.
I think your comments made me realize that distribution also is a very important, like partnerships and distribution, like, because it doesn't make an impact if you have a great product. It's very easy to use and your customers trust you. But if you are not distributed globally, then of course, like, who will know your solution if they are in a different country, for example?
And you won't have much to say in the growth phase of your VC pitches. Yeah. Sorry, Pascal.
Yeah. Yeah, I mean, and also I think not just distribution, but even access, right? I mean, here we are talking with CAM, we are talking about proprietary data. It's not a text file where there is, I don't know, a written piece about how the thing should be manufactured, but this is a binary file that you cannot understand and read if you don't get API access. And so it's really, I think, quite a big determinant whether you get to partner with the big CAM players and they give you access via their API, give you support to while also make your product robust and not just a kind of prototype. And this, yeah, I completely agree that this is a other very, very big component to the game.
Okay, so let's switch to the next question, which is in your product, there's obviously a little bit of AI somewhere, but is it something that the user of Productive Machines or Manukai sees because he's got a co-pilot, an AI thing he chats to, or does it underpin more? Is it more the plumbing of this is how I'm moving data around and making inference and figuring out what the next step's going to be?
I mean, I would disagree with a little bit of AI. I would maybe, I think, put it a bit in perspective, right? I mean, the word AI is by now very much misused. Most people think about large language model when talking about AI. I think AI is much more than that, right? And that's what I also said initially. If we want to tackle manufacturing challenges, we need models, specific models, specialized models for dealing with the type of modalities you find in manufacturing, which is 3D models, which is technical drawings, which is in the end machine data that can be super noisy, very high frequency, a lot of data. Maybe Adam, you can elaborate on that, but that's different challenges, right? This is not something that an LLM will capture. And I think all these components are all, I think, fairly put under the umbrella of artificial intelligence. And then I think what we believe is crucial in any use of AI, and is something that I think we also see when using ChatGPT, is a feedback loop with the user. Or I mean, you need to somehow validate whether your output and the things you generate are correct, and you need the human to tell you that, because only the human expert can determine whether a machine program makes sense, whether a chosen strategy in a CAM makes sense. And an AI cannot, I think, do that judging, because you cannot use the system itself to judge itself. So, and I think that's a critical component. And there, I think the user will also kind of see and get access to the actual learning of the AI, because it will be able to actually tell the AI, hey, this thing is not as it's supposed to be. Please go back and train and get back to me once you figured it out and you're able to actually solve the challenge that I just gave to you.
Yeah. Interesting. Adam?
Yeah, my answer to that question is like machining is really like a complex process. Like there's a lot of parameters that affect the outcome of the process. Pascal mentioned that like we need experts to make decisions. I agree with that. Where my view differs a bit is humans are great in some things, but not great in other things. For example, I have 22 years of experience with machining research and also development since 2003. If I go next to a machine and then if there's a new part on it, like I won't be able to tell like which parameters will work best for that machine. I can only use my experience, which may have accumulated in 22 years, but that experience may not necessarily translate to a new part, new material,
or a new machine.
At that point, physics comes into play, because physics can guide an expert engineer or an inexperienced engineer in the same way. So when there is uncertainty or unknown, basically humans are not great in making the best decisions. And in our experience, usually they do a few iterations and then they say, okay, this is good enough. Let's continue producing this part like this for next 5 years. Of course, they do continuous improvement every year. They improve the process maybe 3%, 4% every year. But after 5 years, they get 15% improvement. And what we have demonstrated is in a week, they get 20, 25% improvement rather than 5 years. So a human cannot say, okay, these are the best parameters. Maybe they will be satisfied with the local optimum, but global optimum is quite difficult. Is quite a difficult challenge for a human.
So, just staying on the topic for a second, do you think that we're going to start developing some large machining models, large toolpath models. It's like specific AI models that are going to learn from all that experience, all that stuff. Because I think the fear that a lot of people are figuring out in manufacturing is that the guys that know how to use those machines, the women that are on the thing that know the right parameters, they're going to retire. They're becoming gray-haired and they're leaving. And when they go, a young kid, a millennial who's only looking at his iPhone all day, will have no clue how to use that machine. And then what are you going to do, right? So, yeah. What do you think? Is that something you guys are working on? Is that something that you're hoping somebody else will come up with? You know, where do we sit on having models that are specifically trained on that kind of data?
I can
go ahead.
Yeah, so we did a project called Coroma. So Coroma was before Corona, so there was no Corona. We had Coroma before Corona. That was about developing cognitive robots for machining applications. So we had a task of drilling. Robots are good for drilling processes. And our task was basically to increase the cognitive capabilities of the robots for drilling applications. And imagine robot is drilling in aerospace applications. There's hundreds, maybe thousands of holes you need on the parts in an airplane. And basically our idea was we will drill a lot of holes, but every time you drill a hole, you of course collect data like torque, power, vibration behavior, and then you quantify the quality of the holes, and then you will you will have a database of like good processes and bad processes. And then the simple approach was, if robot does the same hole in 2 months, robot will disagree with the operator to do that, because it says you did this like 2 months ago, you shouldn't use the same parameters again. So there is this self-learning robots or self-learning machines. It was very popular like in the academic world 10 years ago. Still I think they are popular, but in the commercial world, in the industry, we don't have that solutions yet, but that's going to come. Like, for example, usually the process level of information is just basically, as we discussed, siloed. They just check what's happened in the past. So in the past, by looking to the dimensional qualities or surface quality, but there's a lot of data that's coming from the process, in process. Like we have a lot of data post-process, which is like dimensional data, surface quality data. But in the process, we have a lot of data as well. So that data is not utilized well enough now, but I see that there's a big opportunity there to utilize this data so that machines can learn. As I explained, like having torque data, power data, vibration data will also give us a lot of information about the quality of the process at the process rather than after the process. And there is a big opportunity there.
Pascal?
Yeah, so I actually that leads me to start telling the story from my research times, right? I think it was one of the projects I really liked a lot, right? So what I looked at is basically the question whether you can, like, if you have a system that can be trained to do a separate task, let's say it can do 3 tasks, right? And then it kind of makes sense that you can also train the system to do all the 3 tasks. And then the question was, okay, which one now performs better, right? It's the situation that because you know now 3 tasks, you kind of get some information from all of the 3 tasks, and then you kind of also become better in the other tasks. Or is it different? Is it because you have like kind of lost some capacity because you only can kind of cognitive ability is only limited, or also the ability of the model to capture information is limited to only a certain thing, and if you focus on one thing, you maybe get better in this particular thing compared to being able to do multiple things. I mean, it turns out it seems to be the case that the specialized model always outperforms a generalistic model. And I think it's something that we see in the topics we discussed before with the designer and then the programmer of the machine or the architect and the construction worker, right? I think it's something that also holds true for this kind of algorithms or AI models that, okay, yes, you can maybe train a model that will unify all these NC code and then can maybe understand and interpret a lot of NC code. But I think a model that will kind of be trained specifically for creating NC code for a specific application, for example, in aerospace or any other domain, will always outperform this generalistic model. So while it would be great, right, if manufacturing opens up a little bit and we get more public data in order to do more research and develop better AI capabilities, I believe, especially in a specialized kind of domain like manufacturing, of all these very specialized verticals, it will not be in the end the winner to have this more generalistic model.
So now that we're sort of 4 years into the LLM ChatGPT kind of world, and we've seen the MCP stuff last year, and then a few months ago we had this insane Claude bot, Moltbot, whatever the hell, Open Claw now, right? Where are you guys as skeptical as you were? Because you guys were both more or less skeptical in the beginning. Are you guys skeptical? You think that we're waiting, there's going to be a forest fire, as one of my podcast people said, or the bubble burst and a lot of these startups are going to disappear? Do you think that AI is here to stay? Where do you see it? Where do you see it heading? What do you think is the next phase?
So the article I always reference when it comes to this topic is I think the analysis comparing kind of the big like .NET bubble we had, where I think the Cisco stock was kind of the leading indicator. And I think the argument that was made is basically you saw, okay, the Cisco stock going through the roof, but the actual revenue, so the actual value creation of the company not really growing at that pace. And I think it's something different that we see today, because NVIDIA stock, okay, is going through the roof, but their sales are too, right? That's actual infrastructure that is actually installed, and all this compute will stay. It will still be there, even if, let's say, there is only 20% of the AI companies remaining, right? And then you have infrastructure, so you need to do something with it. And then, yeah, I mean, I think also Erdem with the physics models, right? If he could run, I don't know, 10,000 evaluations in parallel, probably the output will become better. So I think it's a huge opportunity where the established and kind of, I would say, the winners of these now, say, kind of AI race will be in a very good position. And I think there will be a lot of value generated because, and again, right, we install actual infrastructure, and this actual infrastructure is a value driver.
Yeah, very good point, Pascal. Yeah, so I think AI will stay. And also, like as Pascal mentioned, the one advantage is the infrastructure is getting better and better at an incredible scale. And in the past, we were doing like simulations, optimizations, and if you are working on a complex part, it may take like a day. Like if you do like you mentioned about CFD is like one of the most time-consuming or computational heavy solutions. We basically have semi-mechanistic methods. Like we don't we don't position ourselves as a finite element solver, but in the end we solve like some differential equations. Like there's mathematics behind it. And imagine we are calculating forces and vibrations at every few millimeters. And then sometimes toolpaths can be kilometers long. There are toolpaths that we have seen that takes like 400 hours just to machine the parts. And imagine if you are doing simulation and optimization every few millimeters, it can really take ages. But with the infrastructure increase, like with AWS, like now we have had cases like 300 operations on a part are all running in parallel, and then you get a response in like 5-10 minutes. So that's what happened. I think that will get better every year. Because the capability of computation capability is increasing. I think the people will be having quicker results. And I remember a discussion with maybe I shouldn't mention the name, but it was a reputable chem company. He said their principle was basically, why don't you get it now? We want to press a button and then we want to have the results. I said, we are not there yet. Like, imagine we are pressing a few buttons and then our software is running on the cloud or on the premise server and we give a response in 5-10 minutes. But the expectation from that particular company was, why don't we get it now? Like, it will take some time to reach there. But yeah, I think we will reach there at some point, but I don't know why.
Well, I could see quantum computing when it comes of age. It would be a massive use, right? Because if you're solving all these simultaneous equations across, that sounds like a quantum kind of problem, really. In fact, I think I'm going to get someone from a quantum lab in Florida to talk to the Threaded conference in Miami, so that's kind of cool. So let's switch gears and talk a bit about the real world. So when you guys go into your customers, and I know machining is one of those areas that particularly is lagging, but I think of digital maturity on a scale of 1 to 5. One is that people are still using email, and most of the stuff they're doing is in Excel. 5 is basically autonomous, agentic digital twins, which nobody is at. The customers you're going into, are they closer to 1, closer to 3, somewhere between 1 and 2, or 2 and 3?
I'd say it depends a little bit. I mean, in Switzerland, I would say most of the really good, established, profitable, well-run companies, they are quite high when it comes to automation. It's to me also always a bit funny, right? Because you have all this, let's say, hype around also robotics, right? Where it's always like, yeah, I can solve all these manufacturing use cases, but there the reality is it's all already automated with robots. So these companies, they basically work like humans work a third of the time, and the rest is basically all fully autonomous. So yeah, maybe it's somewhere in between, right? Okay, they're still doing this.
Between 1 and 3?
Between one and yeah, probably around a 3. I don't know if 5 is really fully autonomous, right? Because they do 1/3 still manual work, and the other 2/3 are basically already fully automated.
Yeah. In our experience, large companies have expectation that they want to preserve digital threat. So those companies are leading, but again, I don't think they're at 5, maybe 4, 3, like max. And again, with the feedback that we are getting, for example, there were solutions that solves the problem in a siloed way again, but keeping the digital thread was the challenge for the particular solution that we saw. And for that reason, we really paid attention to not to break the digital thread. So everything we do keeps the digital thread traceable. So those companies are leading. But of course, we also want to work with smaller machine shops as well. In those companies, of course, the digital maturity is low because they don't have the resources of the big players. But what is worth mentioning is when people see the effect of the technology, I think it just starts changing their perspective as well. So they see what's possible, and then they can start questioning. Because if you don't know something, it's an unknown for you. So you cannot go.
You don't know what you don't know.
You don't know what to ask. But once you start seeing the benefits, then probably it increases the curiosity, and they go into maybe 2, 3, 4, maybe at 5 at some point. But it will take some time, of course, for the whole industry to go to 5.
Well, that's a great segue into the other question, which is my thesis is that the customers that want to move further to the right, that one of the best ways to do that is to use startups like Manukai and Productive Machines, because you're using physics-informed machining, physics-informed software, using AI. And are you seeing that? Are you seeing customers where they initially kind of very manual, and then they start using Manukai or Productive Machines, and you see the needle literally moving to the right because they're starting to realize they need to break the data silos, they need to have data governance, teams need to work together. The engineers are not your enemy, they're actually your friend, and they could probably, if you work together, you could probably get rid of some of the problems that you're consistently finding on the shop floor. Have you actually seen that in the real world, that kind of thing?
Sure. I mean, it's part of the puzzle, right? It's just, let's say, another component that enables them to be more automated. And yeah, it's a single piece, step after step, I think. I mean, manufacturing always has this kind of bad image of being still very manual, slow, whatever. But yeah, I think it's not really true. I think in many aspects, I always like kind of putting up the thesis that the CNC machine is the first real commercial use case to computers, right? I mean, back in the days, we had this thing that could do computations, and it was not yet even inside that we're going to have personal computers and smart watches and whatever. But use case was, let's move tools in a very precise manner, and I think this innovative kind of drive still persists, right? It's still a very engineering-led community and engineers, I think, are generally very open to try new things. It's just, I think, maybe the reason why it is kind of still there, this kind of perception, is that it's just super hard to bring real value in an already very optimized process setting, right? As I said, right, a third of the work is manual and the rest is already automated, right? This is, I would say, argue a quite high degree of automation compared to, let's say, the law firm 5 years ago, where things were still printed, emails are still printed and put in some folders manually by human labor. So yeah, I think it's a bit. I think we are on a good path, and with the new technologies, we're gonna kind of do another leap forward.
Well, this is sort of a veiled advertisement for you guys, right? Because you guys are a very valid alternative to the solutions out of Sandvik and DS and Siemens and PTC. I mean, but how do you position yourself so that you're showing that difference? And because they're going a lot slower than you on AI, how do you guys use that as a leverage, as a wedge to say, hey, you know, obviously the advantage is using our solution because you can go faster, we're going to learn more, the stuff you can't do today with CreoCam, NXCam, Delmia, etc.
I mean, I would very much argue against this like competitive like positioning you're doing. I think again, it's all part of the same story, trying to get manufacturing forward. In the end, the only thing that counts is the real value generated at the end customer, and whether this is done by an emerging startup that might be a bit more innovative or faster, or by an established player, in the end doesn't matter, right? And I think the same perspective is what is reflected in the very open APIs that you have for most CAM systems that allow us in the end to integrate. And I think they open the door knowing exactly that in the end it only matters what comes out on the customer side, and then you're always going to figure out a way to either coexist and share technology, or be bought up, or I don't know, there is different ways then to go about it. But I wouldn't see it as like kind of a fight between different players in the market, because in the end all try to satisfy the same goals, very often are complementary and to each other, and therefore can very well like coexist in this like huge space that we are anyways operating in.
Interesting.
Yeah, I think the key thing is the value add, like what value you are adding. Like each company must be adding value. If that's the case, okay, of course there may be overlaps, but as long as there's unique value add for each company, every company can coexist. And also, as we mentioned, there's a lot of steps, like we talked from CAD to the measurements. And the big players, of course, want to cover all of it, but they also are aware that they cannot realistically do it just themselves. Like I remember having a conversation with one of these multi-billion companies, like senior manager, and I was saying, like, we are only small, we are 15 people, we cannot do all of it, like we need to go step by step. And then he said, okay, we are thousands of people, but we are in the same boat. Like they also have limited resources. Nobody has all the resources they want. Everyone has their limitations. And even if you have all the resources, you may not have the experts. Like one nice comment was like, guys, we have 7 PhDs in your company on the machining dynamics area. Like, I don't know if there are a lot of companies where like 50% ratio of their PhDs in the company. So yeah, we basically are a deep tech company solving a hard problem called chatter vibrations, which is a 100-year-old problem. And I don't think there is a lot of companies that can solve it. And that's our unique value add. I'm sure Manukai also have their own unique value add. So I think every company who has that will be successful in the market, because there's a lot of things to do in this sector.
I mean, there's an easy saying around it, right? You're not really competing against the corporate. You're competing against the product manager with a team inside that corporate, right? That's I think summarizes it quite well.
Well, I was just trying to think about how it must be still challenging because a lot of companies are going to feel like, well, if I go with a startup, it's risky. They could fail, and then I'm going to be, left in the dark and have to go back to Siemens or PTC or DS at the end of the day. Anyway, so I was just trying to understand the dynamics there.
Maybe one thing that's worth mentioning, I think in manufacturing, at least in my experience, competitors are not the software companies. Competitors are the established methodologies or
the people
of the machine shop. For example, if there's a problem in the machine, I see a lot of people doing this. I don't know what you mean. You understand what I mean? There are knobs, control buttons on the machines that control feed rate or spindle speed. If there's a problem, they reduce the feed rate or spindle speed. Like there's a range, like they can reduce by 50%, increase it by 25%. Usually they take it down, and then if they are lucky, they solve it. They solve the problem, but usually they are not lucky; they cannot solve it, and when they solve it, they lose productivity. But what we have been demonstrating is we usually go faster, and then when we go faster, and when I say faster, sometimes it's 110% faster. So there is no way feed rate or spindle speed override will take it 110% faster. Maybe at max it will give maximum 20%. So yeah, I think our competition is basically this process.
Okay, interesting. There's more, entropy is the enemy rather than anything else.
Yeah, there is no traceability. Like it's all chaotic.
Well, before we wrap up, I'd like to ask about I did a post today about some of the answers that I've gotten to this question. I just wanted to contextualize it in thinking that there's a lot of the demographics on people listening to my podcast and reading my post. About 21% are entry level because I write a lot of educational things, and I think that they probably have a lot of anxiety because of AI, because of all the rumors that AI is taking all the jobs away. But every time I talk to you guys, I get the impression that that's not the case at all, that there's always going to be far more work for real engineers. So I just wanted to get your comment on that. Like, for instance, let's put it this way. 2 or 3 guys come out of a university or maybe 3 girls and a guy, and they're looking for jobs. Why should they go work for Productive Machines and Manukai instead of just lining up like everybody else to work at Meta, Siemens, Dassault, AWS? I mean, what are the engineering challenges that are like so awesome that people are dying to get to work because they just want to work on it rather than a boring corporate job? And what kinds of things do you think it's even like doing that? Is that even a better insurance policy against being AI'd out of a job? Because the challenges are always so much more interesting. I don't know. It's just, I'm spitballing here. Go ahead.
I mean, from my perspective, there's 2 kinds of people. There is people that enjoy uncertainty, that enjoy creating something out of nothing, that enjoy being maybe not guided so much, not be like, I don't know,
Told what to
fenced
do.
so much, not being told so much what to do, like be in the end their own kind of boss, and they like really figuring out and living with this uncertainty. And there is other people that like to be like, they like to have a number up on the wall telling them, okay, this is your goal for today, make the number go up and down. and I would say these are the people that like to go into work with a corporate, and I think the former ones are the ones that like to go to work with a startup where they can really create something new.
And you think that for Manukai, there will always be humans doing 95% of the work, right? Because you've even said yourself, you think AI has a limited role in overall, that you still need all the engineering skills.
I mean, I have a very philosophical take on that, right? I believe us humans, we are always meant, or we always have to create something. So even if I automate everything for you, I'm pretty sure tomorrow you're going to find some new thing that is not yet automated that we can do with it. So that this is just human nature. It is us as humans that are always kind of in this state of trying to figure out stuff and trying to change stuff. And this nature, I think, will kind of not go away, and therefore there will always be new things, new challenges to solve, new new problems appearing, and we're never going to end up in the state where we are just, I don't know, in a like matrix kind of in a capsule, just generating energy to the machines that actually operate the world. I hope so, at least.
So how do you want to tackle that one, Adam?
Yeah, for us, it's more about impact. Like, what is your contribution onto to the world? What is your impact? What is the impact of your work to the like wider economy, wider society? So we are working on a problem, as I mentioned, like it's like 100 years old problem. There's a book called Art of Cutting Metals from 1907. And it's written by the scientific management guru of the time called Frederick Taylor. So Taylor's two life equations, for example, or like he's well known in the management community as well. And he basically said that chatter vibrations cannot be solved. There is no formula or method that can help a machinist to solve chatter vibrations problem. Hence, the operator has to use trial and error. So that's a statement. And that he was right for maybe 60 or 70 years, because it took academic community to formulate the problem and generate some models. And then the first model started in 60s, 70s. There's a lot of models, but there's no company that can solve the problem in production like we do. So we are basically enabling companies to solve the problems that they cannot solve themselves in a very short time frame. And that's really powerful. Like, they see the implication. So the people working in the company see the implications of it. We have a very recent example with a large aerospace company in the UK. They didn't come to us for solving productivity challenge or reducing the cost. They came to us because there was a lot of noise in the workshop environment. Big work, and it's really disturbing. Like, people don't like to work in a environment where the machine is screaming, and they have to wear ear protectors, because if it's more than 80 decibel, it's not safe. So they have to wear like ear protectors. And basically, the requirement was, can you make these machines more quiet? Please don't sacrifice from productivity, because we want to keep productivity. And our guys basically did the visit. They measured the machines. We came back. We ran the optimizations. I think depending on the machine availability, I think we might have gone next week or the following week. And then our guys stood next to the machine. We have like also software that measures the noise coming from the machines, and it can tell us whether the process is chattering or not. And then we run the default original process. It's chattering. It's very noisy. And then we run the optimized process. It's stable, very quiet, and 20 to 25% faster. So when an engineer sees that, of course, like, it gives a lot of satisfaction, because it's something like you can see your work's results very quickly. So this, I think, motivates. Also, the career growth opportunities. So we had recruited, like, when we had the seed round 2 years ago, now nearly 3 years ago, we recruited like 10 people straight away. And then those people work on many different fields. Like, if they had come to a corporate, they wouldn't have the skill set that they achieved in 2-3 years' time with productive machines. So they are becoming stronger individuals in terms of the capability, skills.
Well, thanks. That was a great answer. I love that. We're about to wrap up. I just wanted to ask you guys, other than perhaps Threaded and Warwick on the 25th of March, where can we meet you guys and have a beer in this end of the winter, beginning of the spring? Are you guys going to be at any other trade shows?
Okay, I will be in CRP winter meeting next week.
Nice. Where's that?
Paris.
In Paris? I'll be in Prove It. Unless it's Thursday, then we can have a beer.
Yeah, Thursday. we can meet. We live in a very central location close to Notre Dame Cathedral.
Okay, nice.
And then afterwards, we have the big trade show in the UK called MAC exhibition. So it's the biggest machine tool fair in the UK. Of course, it's much smaller than MO Hanover, but it's good.
Right.
It's nice. And we will have a machine in our stand. So we are a machine tool company. There will be a small machine in our stand doing some real-time demonstrations. So I'm sure
you should bring the machine to Threaded. That could be fun.
timing will be difficult. The machine was on 21st of March, so we'll do some preparations, and then MAC is in 20th of April.
Okay.
The timing wise, we don't have time for the traffic.
That's okay. Well, I hope I'll see you there. How about you, Pascal?
But we'll be in Warwick, definitely. So we'll bring the videos of the demonstrations that we have already done to Warwick.
That'll be wicked. How about you, Pascal?
So we are currently mostly focusing here in the DACH region, smaller fairs, more local events, but definitely gonna meet us at the Hanover Fair this year. And yeah, looking forward.
Well, we're thinking of
Otherwise,
doing
just reach out. Our office is always open. Beer is cold. Just
all right,
drop by.
I'll definitely be going to Zurich to do that for sure. And we're probably going to do a Threaded Germany later in the year, probably in the fall. So probably in Munich, so
cool.
not very far away from Zurich. Once again, thank you so much to Erdem and to Pascal. Had a great discussion today. I think I certainly appreciate a lot more about machining that I didn't know before, and I appreciate it. Thanks for taking your time and joining me. Thanks to the audience. We were up to about 12:15 also, so just like the last three. So we're on a good curve, and of course it's a long tail kind of thing. There'll be lots and lots of impressions. So please, if you have any other questions, put them in the comments. Erdem and Pascal will come in and answer your questions, and of course, feel free to reach out to them if you want any more information. And of course, if you're a student and you want a job, they're always hiring, right? I mean, that's what startups do.
Exactly. Yes.
So have a fantastic weekend. Thanks everybody, and
Enjoy.
we'll see you on the. Well, oh sorry. One thing I'm going to be. I'll have my own. I'll have a podcasting booth at Prove It on next Tuesday from about 1 p.m. Texas time to 4 p.m. Texas time. So basically European late afternoon, evening. And I'm going to have a really cool manufacturing startups coming through there, Fuse and Highbite and Avalara and stuff. So stay tuned. I'll put a link up. There'll be a live broadcast from there. And in any case, have a great weekend, and we'll talk to you soon.
Thank you, Michael.
See you around. Bye-bye. Thanks.